Okay, let's dive right into this explainer and completely flip how you picture one of the most famous prehistoric creatures of all time. I mean, when you hear Pteranodon, your mind probably jumps straight to, some shrieking, leathery-winged monster plucking people off the ground in a summer blockbuster. But the reality that paleontology has uncovered, it's so much richer. It's wildly fascinating and honestly a lot more beautiful than anything a special effects team could dream up. Today we're going to use actual fossil evidence to rebuild this magnificent creature from the ground up.
Just picture this incredibly cinematic scene from our source material. 85 million years ago, the shadow of a giant aerial creature moves over the frothing tops of a rough sea. It's a gorgeous image, right? And it grounds the animal in reality. It tells us that the real world of the Pteranodon was far more majestic than the movies. They weren't hiding in spooky caves waiting to ambush dinosaurs, no. They were dominating the ocean winds, living out an existence totally tied to the sea.
Section 1. Not a movie monster. Busting pop culture myths.
We really need to just take everything Hollywood taught us and throw it right out the window. The pop culture pterodactyl is this terrifying monster with a mouthful of razor-sharp teeth and eagle-like talons that can lift heavy prey. But the reality is just vastly different. The real Pteranodon had a toothless beak, incredibly weak claws for its size, and lived a surprisingly humble seagull-like existence. It's a huge gap between fiction and reality. They were absolutely not apex predators of the land. They were highly specialized coastal flyers.
So, the crucial thing to remember here is that they weren't birds, and they actually weren't dinosaurs either. They were pterosaurs, specifically pterodactyloids. This was a highly evolved group of flying reptiles that emerged back in the Jurassic period. Now, unlike earlier flying reptiles that had short, fat wings and sharp teeth, pterodactyloids evolved long, thin wings that were just perfect for soaring huge distances. And brilliantly, through convergent evolution, kind of similar to birds, they entirely lost their teeth. Why? To shed weight. I mean, literally every ounce matters when you're trying to glide over the open ocean.
Section 2. An ocean in Kansas. The Western Interior Seaway. Now you might be wondering, how does a creature built for the sea end up buried in the middle of modern-day America? Well, it starts 90 million years ago when an ancient sea essentially split North America completely in half. Fast forward to 1871, and the famous paleontologist Othniel Marsh is digging in Kansas, smack in the middle of the American Midwest, and he discovers these fragmentary wing bones. Early paleontology was kind of just figuring things out on the fly. It actually took another 5 years for a complete skull to be found, and only then did they realize it was completely toothless, officially earning the name Pteranodon. I absolutely love this fact. Landlocked Kansas once had a coastline where these giants soared. It was called the Western Interior Seaway. Because global temperatures during the late Cretaceous were so much hotter than today, sea levels were drastically higher. This created a rustic, thriving coastline stretching all the way from the Gulf of Mexico, thousands of miles up into the northernmost reaches of Canada. So, when you drive through the flat plains of Kansas today, you are literally driving across the bottom of a prehistoric ocean. How wild is that?
And this brings us to a monumental case of mistaken identity. See, while the Pterodactylus, which was discovered much earlier over in Europe, had a row of sharp teeth, our North American Pteranodon was completely toothless. But back in the 1870s, scientists just assumed all pterosaurs had teeth. So when they found some massive, terrifying fossilized teeth near the Pteranodon bones, they just assumed they belonged to it. Turns out, those teeth actually belonged to a giant, monstrous prehistoric fish named Xiphactinus. Early scientists completely confused the two, which is exactly why people still wrongly call Pteranodons pterodactyls today.
Section 3. Anatomy of a giant. Thousands of specimens.
The really incredible thing about pteranodons is that they aren't some mysterious creature we only know from a single crushed bone. Because we have literally thousands of specimens, we know an incredible amount about their anatomy, including some very distinct sexual dimorphism. We can clearly categorize them into two main types. The females were smaller, featured a much wider pelvic canal for laying eggs, and had this small, rounded head crest. The males, on the other hand, were massive, with bodies larger than a fully grown man and sporting that iconic, sweeping head crest. Scientists strongly believe males use those enormous crests to show off, kind of like a peacock uses its feathers. Okay, let this number sink in for a second. 6.5. That is 6.5 meters. That is the staggering maximum wingspan of some of these enormous individuals. They were the undisputed largest flying animals to have ever existed, at least right up until the discovery of the Asdocod pterosaurs in the 1970s. Let's really put that 6.5 meters into perspective. That's more than twice the size of a wandering albatross, which is the largest flying bird alive today. In fact, a male Pteranodon in flight was closer in size to a small airplane than to any living bird. Imagine standing out on a prehistoric beach and one of these just lands right next to you. It would stand roughly eye to eye with a fully grown adult human. Standing eye to eye with an animal the size of a small plane. It just blows your mind when you really picture the sheer scale.
Section 4. Flight and Fishing. Navigating the Ocean.
So, how exactly does a living airplane take off from the ground? Or, for that matter, from the water? To understand how they flew, we have to look at their wings, which were totally alien compared to modern birds. Unlike birds, whose wings are strictly their front limbs while their legs remain totally separate, pterosaur wings were actually formed from a membrane wrapping around both the front and the back legs. It's much more comparable to a bat, really. Their hind legs were literally part of their wings. And that completely changes the mechanics of how they moved and, most importantly, how they managed to get that massive body up into the air.
Because their legs were incorporated right into their wings, they couldn't just run and jump to take off like an albatross. Instead, they utilized what researchers call the quad launch. First, they'd plant their sturdy, folded forelimbs firmly on the ground. Second, they would catapult their body forward. And finally, they'd push off powerfully with those hind limbs. This quad launch maneuver actually generated twice the force of a normal bird taking off, launching them into the air like a biological catapult. It's a remarkably efficient way to get a massive animal airborne.
But once they were up in the air, a huge mystery presents itself. With incredibly weak claws and this massive, cumbersome wingspan, how did they actually catch their fish? Remember, they didn't have eagle talons to swoop down and grab prey. Yet, we know for an absolute fact they ate fish, because we've actually found whole, fossilized fish perfectly preserved right inside their stomach cavities. So here's how researchers think they pulled it off. One major theory is skim fishing, basically flying elegantly close to the surface and just dipping their lower beak into the water to snatch small fish on the wing. However, recent studies on their anatomy show their head and neck vertebrae were remarkably robust, and that leads to a second, much more thrilling theory: plunge diving. Just like a modern gannet, they might have folded those massive wings completely submerged into the ocean to grab a fish, and then use that powerful quad launch we just talked about to blast off directly from the surface of the water.
Section 5. The Prehistoric Food Web. Surviving the Cretaceous.
Now, being the size of a small plane didn't make you safe 85 million years ago. In fact, it kind of just made you a larger meal. While the majestic Pteranodon was busy hunting small fish, they were sharing the Western Interior Seaway with some absolute aquatic terrors. We are talking about giant, prehistoric sharks that grew significantly larger than modern great whites. We're talking about mosasaurs, these huge, vicious aquatic lizards. Even massive predatory turtles the size of rhinos. The oceans of the Cretaceous were absolutely not a safe place to go for a dip, even if you were a giant flying reptile. And we actually have the ultimate proof of this dangerous dynamic. Paleontologists found a giant shark tooth firmly embedded inside the neck vertebrae of a Pteranodon fossil. The incision in the bone clearly shows it was a direct bite. Now sure, it's possible the shark was just scavenging a dead Pteranodon that fell into the sea. But this incredible piece of fossil evidence strongly suggests they were likely right on the menu for prehistoric sharks that could just burst from the water and pluck them from the surface.
So, as we wrap up this explainer, I really want to leave you with a final thought. When you picture a Cretaceous sunset now, do you still see that screeching movie monster? Or do you see a majestic, humble giant using its incredible 6.5-meter wingspan to soar like a seagull over a vibrant, dangerous inland sea? The big takeaway here is that reality is often so much more complex and frankly more fascinating than fiction. The fossil record gives us this awe-inspiring, true picture of an incredible animal. Next time you look up at a modern seabird diving for a fish, just imagine it 100 times larger, ruling the skies of a lost world. Thanks for diving into the evidence with me.